Now if you want to put a graph of comparison of mean angles or some values, so you can go to that mean values, select those mean values. Now this is mean value of what?
Female.
Male carrying angle. Okay, mean value of carrying angle of right side, comparison with the mean value of carrying angle of right side for females. So now 4 values we selected. Go to insert and put a diagram. You will get a mean differences. So in this diagram you can see female carrying angle is more than the male carrying angle. Okay. Now like that you can do for any of comparisons. You can do comparison of age, comparison of weight, comparison of height, comparison of BMI, average BMI, comparison of any mean values. These figures should be there in your results. These are the things which you need to write in the results. My statistics I have done with this, and my results of mean age of male is this much, mean age of female is this much, mean weight of male is this much, mean weight of female is this much. Like that you should put it in tables and graphs in the form of writing. In these 3 forms you have to do your results. Now next thing is bivariate. Now 2 variables together we are going to analyze. 2 variables means if you want to see correlation. Now correlation means as the age of the person is increasing, the height of the person should increase or decrease? Increase. Okay. As the age of the person is increasing, the weight of the person should increase or decrease? Maybe increase, maybe decrease. So this is what is correlation. So once one value is increasing or decreasing, what happened to other value, whether increases or decreases? That is what is correlation. Okay. Now how to do this correlation? Now to analyze the correlation, we can do with age versus height, age versus weight, age versus right side cubitus angle, age versus left side cubitus angle. And we can do opposite, height versus weight, height versus cubitus angle. We can do any correlations. But majorly what we require, what is our outcome measure is cubitus angle. So we have to do cubitus angle versus all other outcome measures, whether correlation is there or not there. So correlation, when you want to do correlation, again go to fx. If you put correlation, you may get Correll, Pearson, Linus, Fisher. The most common, there is a parametric test and non-parametric test. Parametric test means if the values can be added, subtracted for all those things. If you want to do correlation of parametric values, then you will select Pearson. So when you select Pearson, it compares 2 values. Now what you want to compare? I want to compare age. So here is the age B. Okay, go to here or type B2 B 274. Excellent. And compare with what? We will see height. Whether age increases, height will increase or decrease. Okay? Where is the height?
D2.
D2.
D274.
D274. What was the value? Negative. So when the values are near to 0, there is no correlation. When the values are towards 1, okay, towards +1, that means it is a positive correlation. That means one variable increases, other variable also increases. If it is negative towards -1, value, one value increases, other value is decreases. Now clearly examine the value. It is 0.1 minus 0.1. This is near to 0 or near to 1?
Near to 0.
Near to 0. That means no correlation. Okay? If the values are 0.25 to 0.5, there is a mild correlation. 0.5 to 0.75, moderate correlation. 0.75 and above, greater than 0.75, this is very good correlation. Okay? More than 0.9 is excellent correlation. If the values are more than this, now 0.01 is less than 0.025.
Yes.
Okay, so that means no correlation. That means no correlation between height and age in your sample. Height and weight of your sample. Now we will see same thing, whether it is applicable for so now what it is comparing? This is E2 versus G2. We don't want E2. What is G? This is G. This is G and this is E. So we want here comparison of Pearson. Okay, Pearson. What all things you want to compare? Age with huh?
With F.
Age with the cubitus valgus angle. Okay. So where is the age?
D.
B. So B2 to B274 with what? Cubitus valgus, which is there in F2 to F274. What is the value? 0.15. So that means no correlation because it is near to 0 and less than 0.25. Now we'll see height versus weight. Okay, we'll see height versus weight. That means as the height increases, that means D2 B274 versus E2 E274. In your sample, that also no correlation. Whether height increases, no problem. So this is how we will do correlations. Age versus cubitus valgus. Height versus cubitus valgus. Age, the weight versus cubitus valgus. BMI versus cubitus valgus. We can do all the correlation. Now we will see right versus left. Okay? Right cubitus valgus versus left. Is there any correlation? So here nobody will talk. F2 F274 versus G2 274. What is the value here? 0.93. That means very good. So that means when right side cubitus valgus is more, it indicates left side cubitus valgus also will be more. This is called positive correlation. Okay, this is called positive correlation. Any doubt in correlation now? Same thing you have to do for female. Same thing you have to do in each age. Same thing you have to do for female. Same thing you have to do for each age. Maybe there may be chances that one age group may be having correlation, other age group may not have correlation. So the values has to be done for each age, each gender and the total sample together. Now